So welcome to the European Cassandra Summit 2014, Jimmy.
Thank you very much.
So Jimmy, why don't you introduce yourself, tell us what you do.
So yeah, I'm Jimmy from Spotify. I'm the tech product owner of a team at Spotify that's responsible for the Cassandra infrastructure at Spotify.
So all right, Spotify, of course, I know what it is, I love it. What about those people who live under a rock that have never heard of Spotify? What do you tell people about Spotify?
So Spotify is a music streaming service, bringing you the right music for every moment, be it on computer, mobile, or tablet. We're essentially your music wardrobe. We have all the music that you can ever want to listen to.
I like the all-you-can-eat family.
Yeah. So the difference between us and many of our and before is that you don't have to buy your stuff. You're buying access to music.
So I would suspect that you probably have a few data challenges there.
Yeah, we have a lot of challenges when it comes to data.
So, what are some of the use cases that you use Cassandra for?
So we're using Cassandra for it's really our de facto database when we want to store data. To be highly available and used by many users, and we have a lot of users. For example, all our playlists that you have created are stored in big Cassandra clusters, but we also use Cassandra for social networking. We're using Cassandra for storing music collection, recommendations, and everything.
So that was actually one of the first presentations I saw you guys do as a playlist. You had a really interesting playlist application. Of course, I appreciate that as a Spotify user that my data is probably going to be there. When I save something on my playlist, it will stay. But would you say that, what was one of the main reasons you used Cassandra?
So when we started at Spotify, we had this problem of how do you store data reliably for millions or hundreds of millions of active users. And because we're building our own data center, because we want really low latency when you play music, we had to figure out we need to host our own databases. And we tried out many different kind of databases, relational ones, they didn't scale as very well as you know. We tried out some other ones. And then we found this Dynamo paper, which is famous. We started
famous Dynamo.
Yeah, we started building something on top of that. It was miserable. Let's make a second attempt. But hey, wait, we have some guys here that have done something based on this as well, which seems to be everything we want.
Right.
It's based on Dynamo. It uses immutable log structure storage, immutable finds, seems very durable. So we decided to give it a shot.
So, all right, I'm going to ask the question because I know probably people are thinking this. You actually store music files on Cassandra?
No, we're not.
Okay, that's a bad use case, right?
Yeah, that's a bad use case because Cassandra, you typically store structured data in Cassandra. For big data files, like big music MP3 files or whatever format you're using, you typically store that in big storage or CDN or something like that.
So, if you were to summarize a use case, if someone was learning how to use Cassandra or wanted to use Cassandra, what would be a great use case for Cassandra?
We use Cassandra for many different use cases. Typically, the way Spotify works, we have a microservice architecture. So we have a lot of small services doing one thing and doing one thing well. And each of these services need to store data. The data that service needs to store is usually fairly simple. It can be a simple key value store. And you can use many databases of key value store, but Cassandra is excellent key value store. It brings all this durability and everything. But then, of course, Cassandra is so much more. You can use it also to store time series data. It's excellent storing time series data. It's excellent at storing many different kinds of data. And it's really this high availability and multiple data center support that made us use Cassandra for almost anything. So I think there is almost nothing that you couldn't use Cassandra to store.
So recently, we don't have to talk about exactly what the feature was, but you and I were talking about multi-data center is becoming the problem to solve, right? So would you say that's probably one of the primary reasons?
Indeed. So when we were talking about the storage problem, one of the concepts that we tried out and really regretted doing was something called home siting, which meant that you as a user only stored your data in the data center where your user account was created. I still think that's a fairly common thing, and it works horribly because data centers, you want to do maintenance, you can have routers going down or switches, and we want to be able to shift users from one data center to another without losing the data.
Right.
Using multiple data center replication in Cassandra gives us that.
And no doubt you've had a data center go down before.
Yeah, either because of the provider doing something bad, or switches gone wrong, or any kinds of problems. They can be. I mean, you can have network partitionings between data centers. There was
Things happen.
Yeah. A couple of months ago, there was this shark that took a bite of the transatlantic cable, and this is actually no joke, causing really problems with our replication between clusters. But it was fixed later on.
Well, I always tell people that if you're getting anywhere close to 100% uptime, you have to be in multiple data centers.
Yes.
It absolutely has to be. So it's clear that that's what you're doing right now.
Yes. And it's also multiple data center gives much better latency.
True, that's probably true. Now, with your microservices architecture, does that meld well with what Cassandra does for you? I mean,
yes.
like being distributed and highly available.
I mean, so what we're doing for Cassandra when it comes to microservice architecture is that we're actually using many Cassandra clusters. So that's something I believe that maybe not so many companies are using. I think it's a more common scenario that you have just one or two or very few Cassandra clusters, and you have many key spaces to store a lot of data in there, and then you have one DBA or two DBAs handling all that. Instead, we're going in a different direction and have very many Cassandra clusters, one for each of these microservices, which makes each cluster much easier to maintain, and it's easier to performance profile it, and easier to, if something goes bad, you're only affecting one part of the entire service.
And so that's interesting. That means that you're pretty decentralized with your Cassandras.
Yes.
So
yes.
Who do you have one team that manages all your Cassandra installations, or is it how does that get managed?
So once upon a time, until after a year ago, we had, yes, indeed one team that did all the DBAing and managing Cassandra and working on Cassandra upstream. But then there was a shift about a year ago where the operational responsibility was pushed out from this centralized team, and this is not only Cassandra but any operations within Spotify, from one team to all the teams that are actually developing the features. So we're pushing out the responsibility, share the load, spread the pain, and as a developer, when you have to get up in the middle of the night to fix the code, you get very much more careful what you put in production.
That's becoming more of a common theme, and I think that's great. I mean, it makes you move a lot faster, I think.
Yeah.
So, and that's good. As a user, I like to see more features coming.
Exactly.
And less downtime is awesome.
Yeah.
So thank you.
So when we made that change, there was this will probably not work well initially. We thought in the long run it would work well, but it actually turned out that uptime went up right away from the start.
Oh, that's great.
Yeah. Wow. So we were a bit positively surprised by that.
So you're doing a talk today?
Yes, we'll talk today.
So what are a couple of highlights of things you're going to be talking about?
So I will talk about exactly what I just told you, that how we operate Cassandra model, this decentralized model, spreading the pain, not having this small team operating Cassandra clusters. I will explain how we came to use Cassandra. And then I will talk a bit about repairs, which is, as Jonathan explained this morning, is the very common pain in Cassandra. And finally I will talk about data compaction, which is a recent invention that we did at Spotify and which is now available.
So that one is actually something you and I share a little common ancestry on, because that was something that I was very interested in early on, and then I was in Stockholm last spring, and I met Bjorn.
Yes.
So now Bjorn works for Spotify.
Yeah, he does.
Can you tell a little bit of how that came about?
Yeah, so about a year ago, we had our main Cassandra engineer, Marcus. He came up with this idea of that for time series data, none of the compaction strategy is size tier or level tier is actually perfect for the use case. So he came up, we could do something different about this. And then we had this master thesis student who wanted to work on Cassandra, and we thought that was a perfect fit. So that's how it really got started. And
so really it's about maintaining a different compaction strategy around the fact that you know that the data is immutable, that it's going to have a long tail, and stop recompacting data that's already been compacted.
Yeah. So it's organizing the data based on the knowledge on how the writes will look like.
Mm-hmm. So you're using that in production right now?
We're using this in production right now.
So what have you seen? What are some of the benefits you've seen?
It's only been in production for like 2-3 weeks, so unfortunately we haven't gathered as much data on it yet. We're using it actually we have several use cases for it. We're using it for actually a case right now with TTL data. So one other benefit of data compaction is that if you have a lot of TTL data, you can actually drop entire SS tables at a time because you're not mixing all the new data.
Because all of that time series data, or the data that's in a certain time frame, fits in one file.
Yes, exactly. And then you can drop it. So you get, if with TTL, sometimes you get tombstones and that you can't easily compact away. But with data compaction, you can actually drop the entire SS table because you're not mixing all the new data.
So that actually, that sounds like a great idea, because you're just deleting a file at that point.
Yes, so, and that works very well. For time series, we're still just very early on in testing phase, so I can't give you any numbers, but we did, when it was developed, we did run it in server mode for a long time in production, and saw that the performance was much better.
So are you looking at using this for more of an operations need, or is it for performance, or read performance?
I would say it read performance, mostly.
So, and that's really one of the keys, is that it gives you the same read performance as level compaction.
Yes, exactly.
And a lot less compaction, like size-steward compaction.
But for a typical case, for instance, where we're really where we're trying this out now, where it's that we have this Cassandra cluster that monitors all services at Spotify,
right.
Thousands of them, and there's a lot of metrics that come in and it's your standard time series use case, and then we have all the graphs and everything. And I mean, the most common thing is that you only want to look at the graphs from the latest day or latest week, but we store it for an entire year.
Right.
But all that data is old. You can query it when you want to, but usually just query the latest data. So this is exactly what you would like to use data for.
So I'm excited about this, because this has been something I've been wanting for at least a year or two, and so I've been anxious to watch and see how it goes. So I'll probably be hitting you up again and see how things are going. And maybe the next Summit talk will be on how it works in production.
Yes, I would be happy to talk about that.
So final thought. So someone's getting started with Cassandra. I mean, what advice would you give someone to starting with Cassandra, especially in a large organization?
If you get started with Cassandra today, you should realize that you will get exposed to SQL immediately, but SQL is not SQL. So you really need to understand how Cassandra works. You can't just assume this is, now I can use Cassandra as a relational database, because you really need to understand data modeling. And there's a lot of excellent guides out there on how to get started with that, but also how to set up Cassandra clusters. Make sure you read up on best practices. I think the documentation on the DataStax website is just fantastic. Just take your time to read through that, and you won't make very many mistakes at least.
And if you make a mistake, there's plenty of people to help.
There's plenty of people to help. And a mistake, you learn. You learn from making mistakes.
Yeah, and thank you for being a part of that community too.
Thank you.
I did a meetup there, and I think that was probably one of my biggest ones. It's a great place to do a meetup. You have a great space. Okay, well, thank you very much for being here today.
Thank you, sir.